The system has three main building blocks: data uploading, record selection, and the visual prediction. The user starts the process by uploading time series records to analyze. In addition, he can upload a mapping file that contains the file names mapped to its record. In our demo, we will be using CSV files of 50 stocks from Yahoo Finance. Once the files are uploaded, he can search for a record by its map name or finding records that match certain criteria based on their past values. The user can then select the desired record to analyze further. The system computes the prediction based on two inbuilt models, the SVR and LSTM. It initializes using the default parameters. The visualization shows the main details tab, an overview tab, and the two prediction lines on the right. The system by default uses 1 year of data and makes predictions for the next 30 days. This can be modified by the user to the desired values. The user is provided various tools to comprehend this data better. Events, such as news or any custom files, can be added for the analysis. This is displayed as histogram bars corresponding to the number of events on that particular day. Clicking any bar shows the details of the events. The system also provides sequence matching to find the data sequences that are most similar to the two predicted lines. The user can select the model-based similar dates option. This highlights the starting dates of the two sequences that have the highest similarity to the predicted lines. He might want to analyze the events corresponding to that period to get further insight or study what conditions were prevalent then. Evaluating the past performance of a model is particularly important for the user. The user can see how the model would have predicted a given time instance by selecting that point and observing how the different models would have predicted the values. In this case, SVR seems to be closer to the actual value at the end of the period. At the same time, the user can also evaluate the likelihood of any value by adjusting his expected percentage changes for that period. The system then calculates all the points in time when the values have changed by a similar percentage. This helps the user make more informed predictions based on its past performance. The system also uses the concept of weighted prediction. The user can select any number of regions and give them a higher weight than the rest of the input data. This is useful when the user might have additional knowledge about the record or effect of a past event. By adjusting the weights, the user is able to steer the predictions, making them more reflective of the actual situation. Observing the model's original prediction and the weighted prediction, he can then dynamically update the weights of any region and see how the results change. In this case, we can see how adjusting the weight brings both the models closer to the actual value at the end of the period.